we're going to look at the ratio test, the ratio test. And just remember the ratio test. In this ratio test, we are looking at the n plus 1 term divided by the nth term, and we're looking at the limit of that as n goes to infinity. So if this limit is less than 1, we get convergence. If the limit is greater than 1, we know the series is divergent. And if the limit equals 1, well, we don't know anything. We've just wasted our time a bit, and then you've got to test. That comes in the P-series stuff, and we have to test and things like that. But we're looking at the nth plus 1 term divided by the nth term, and we're looking at the limit as n tends to infinity. Now, these questions often involve, nearly always involve fractions, and often factorials and powers and things like this. So let's have a look at how this works. Does this series converge? So what we look at is we look at the limit as n tends to infinity of the nth plus 1 term to n plus 1 over n plus 1 factorial. And we're going to divide that by 2 to the power of n over n factorial. So the nth plus 1 term divided by the nth term. And we're going to take the absolute value of that. So let's write that out a bit nicer. It's going to be the limit as n tends to infinity of 2 to the power of n plus 1 over n plus 1 factorial times n factorial over 2 to the power of n. So that's basically what we've got. If we cancel out here, we've got the limit as n tends to infinity of, 2 to the power of n can cancel out with 2 to the power of n plus 1 and just leave 2 up top. N factorial divided by n plus 1 factorial leaves an n plus 1 at the bottom. Now, we look at the absolute value of this. This is obviously heading towards 0, or the limit as n tends to infinity is less than 1. Therefore, the series is convergent. Okay? And that's all the ratio test is, and it's always pretty much the same. As I said, it really relies on fractions here a lot of the time, exponentials and powers and things like that, because then down here things cancel out. So anything with powers, anything with exponentials, often this is the case, and we use that. Let's have a look at another example. Does this converge? So what we've got here is the sum as k equals 1 to infinity of 3 to the power of k over k squared. So we're going to use the ratio test. We're going to look at the limit as k tends to infinity of the absolute value of the k plus 1 term, so 3 to the power of k plus 1 over k plus 1 squared. And we could do the same sort of thing, and we will. This is all divided by 3 to the power of k over k squared. And we're going to flip the second term and multiply, because we've got a fraction of a fraction there and things like that. So we get the absolute value of 3 to the power of k plus 1 over k plus 1 squared times k squared over 3 to the power of k. Okay, so what does that look like? Well, these can cancel out to leave a 3. Okay, so what we've got is 3 times the limit as n tends to infinity of k squared over k squared plus 2k plus 1. And all I've done there is expanded this. Now, if we think of it, and that should be a k, if we think of the limit of this, I can see that the limit of this is going to be 1. As k tends to infinity, the limit of this is 1. We could do it mathematically properly, I guess. Divide everything top and bottom by k squared. And what we get is 3 times the limit as k tends to infinity of 1 over 1 plus 2 over k plus 1 over k squared. Now, as k tends to infinity, this becomes 0, this becomes 0, and we've got 3 times the limit of 1 over 1, which is obviously greater than 1. Therefore, this series is divergent. Okay, and that's what the ratio test is. We always look at the same thing, the nth plus 1 term divided by the nth term, and we look at that as it goes to 0. It doesn't tell us, we look at that as n tends to infinity, or in this case, k tends to infinity. Okay, hopefully that helped a bit.